Today I'm going to tell you all about the relationship between the length of of the arc of a circular sector and the degree measure of that same arc. Alright, so the one thing that you're going to want to think about when doing this is this right here, part to whole. Basically why I say this is that each side of the equation involves the part of the circular sector in reference to the entire circle. So the equation that you're going to want to use here is this one. Theta over 360 is equal to A, which is the abbreviated version of arc length. Actually, I'm going to do that right there. Over C for circumference. And this is how you're going to want to find either theta or how you're going to want to find the arc length. So I'm going to use an example of how you can do this here. Let's say you have a pizza of diameter 10. You pay 20% for this pizza. How much, or what is the degree measure of this slice, assuming that you get what you pay for? Alright, so knowing that pi times 10 is equal to 31.416, we can do this. Knowing that you pay 20%, this means that your arc length of the pizza would be equal to 20% of the circumference. So when we do that, we get 6.283. Now if we put 6.283 over the original 31.416 and and using the formula, we know that that's equal to theta over 360. If we multiply theta by 31.416 and multiply 360 by 6.283, and then we take this number here and divide it by 31.416, we're given 72. So that's just an example on how you can use that.
So using the angle you just found, you can find both the circumference and area of the sector. So first, for circumference of that little sector, you use circumference equals theta over 360 times 2 pi r. So you plug that in to get this equation, and once multiplied out, that will equal circumference equals 12.566 inches. And so then for the area, you'll use a very similar formula of area equals theta over 360 times pi r squared. And so you'll plug in all the known information and multiply that out to get an area of 62.832 inches squared.